Hey guys, I had a question on number 2 from the algebraic proofs assignment. I just wanted to run through that. I thought if I'm going to make a video for it, I'll just post it for everybody. And you guys can kind of use this as another example to kind of help you get going on that assignment if you need it. So on number 2, we start with a given, which is -4 equals 4 plus v over 14, and then we have a minus 3. And what we're trying to prove is that v is equal to -18. Okay, so our given, and then what we're trying to prove. So we're going to do a 2-column proof for this guy. And over here on the left is where our statements are going to go. And then over on the right is where our justifications are going to go. Okay, now when you're starting a proof, you always want to start with the given information. So what do we have, what are we being shown, or what are we being told, and then we know we're going to have to end with the statement we're trying to prove. So the first statement here is just going to be the first one. Okay. And then the justification here is that this was just given to us, right? Now at the very, very bottom, sometimes I don't write this always because I don't know how much room I'm going to need, but we know that the very last statement is going to be something like this. V equals -18. Like, that's where we want to end. If we can get to this step, all we have to do is a justification. We know we're done. We know we've gotten to where we want to go. All right? So that's kind of how we're going to start this out. Now again, sometimes I don't write this, even though I know this is going to be my last step. I won't always write it because I don't know how much space I'm going to need. So the first thing that we need to do to solve this, or there's multiple ways to solve it, but what I would do in this case is I would just add 3 to both sides. That's the first thing I would do. So add 3, add 3. Now remember that we don't really show the work. Like, I wouldn't put a +3 and a slash and a +3 or whatever. I'm just going to get to the next line. So if you want to do the work off to the side, that's okay. We just want the next statement that's going to go here, which is kind of showing your steps along the way, but we just don't see like the little scribbles and crossing stuff out, because we want this to be really clear and readable. So if I add 3 to this side, this is going to cancel. If I add 3 to this side, I'm going to just have -1. So -4 plus 3 is going to be -1. Okay, and what I did here is I added 3 to both sides, right? The property that says I'm allowed to do that without, changing the fact that these sides are still equal is the addition property of equality. So I'm going to do add prop of equality. So it's okay to abbreviate as long as we're clear on which property we're using, right? Because we don't want to just say addition, right? We did add, but that's not what we're saying here. We're not saying what we did. We're calling upon some kind of property, some kind of definition, some kind of postulate to be able to justify what we did. So not what did we do, but why do we know we can do what we did, right? And that's a property here in this case, addition property of equality. Okay. Next thing I want to do is kind of get rid of this fraction. So what I would do here is I would multiply both sides by 14. So if I was showing my work, I might do something like this. I'm writing it really lightly so that I can erase it. But that's what I would do, multiply both sides by 14, right? Which is going to cancel out this 14. That would leave me with 4 plus v on the right of the equal sign, and then on the left I'm going to have -14. Okay, now again, this part we don't really show. I wanted to show you what I was doing, but we don't want to write that down. We could do that on a separate part, scratch paper or whatever, but that's what's happening here. And the idea that we can multiply by the same thing on both sides and the statement is still balanced or it's still true is the multiplication property of equality. So mult prop of equality. Again, don't just write multiplication, because there are properties of multiplication. Like, there's the distribution property of multiplication, and there's the commutative property of multiplication, and there's the associative property of multiplication. So you can't just say mult, we have to be specific. We're talking about a property of equality here, and specifically it's the multiplication property of equality. Okay, next up we are going to subtract 4 from both sides. So if I were to kind of show that, it would look like something like this. I would cross this out and I would get a -18 over on this side. And then once this crosses out, I'm just going to have a v. So I'm going to go back and get rid of that work, because that's not something we're going to show here. We're just going to show the next statement. And in this case, that would be the subtraction property of equality. subtraction prop of equality. Now again, we need to be careful here because there is a substitution property of equality. So if you put sub prop of equality, I can't tell if you're talking about subtraction or substitution because they both start with sub. So if I'm going to abbreviate subtraction, I'm going to have to do a little bit more than just sub, so I know that we're talking about subtraction and not substitution. Now if you want to write it all out, to be clear, that's totally fine. You can do that. Substitution property of equality, subtraction property of equality is what we want here. Okay. All right, now, is this the statement that we wanted? Not exactly. It's very close, and it's equivalent, right? It's the same kind of thing, but we want to end with this guy. So all we got to do is switch sides, and we have to remember what property of equality says we can do that. The property that we need here is the symmetric property of equality, saying that if I reverse the order, it's still going to be a true statement. So going from here to here, the last statement here is we need the symmetric prop of equality. If we need to change the order around, that's the property that we're going to use, right? Switch the side with the variables on. Okay, so that's how you go about doing number 2. Some people were asking me about, printing out and writing and stuff like that. I didn't really think too much about that because, most of the time in math class we need to show our work, and there's like all kinds of math symbols that we use that are kind of hard. In this case and in this assignment, I think it makes sense to be able to just type this stuff out. You can do that on this assignment if you like. I had some questions on whether you can just type in the doc, the copy of the doc that I gave you, and turn that in. That's totally fine. In the future, we might not be able to do that. It just depends on the type of assignment we're having. So if it's something that you can type out and it's a document that you can type out in, great, that's totally fine. You can do that. Just make sure that you're clear, make sure that your formatting is correct and everything looks good. A lot of times though, we're just going to have, we might have worksheets or things like that where you will have to kind of show your work. So again, on this one, totally cool. You can just type right in the doc if you want to. If you've already printed it out, typed it, and taken a picture, that's also fine too. So we'll be a little bit flexible here as we learn the ropes and kind of figure out what's going to work best for us. And I'll try to be a little bit more clear on that on the instructions the next time around. So thanks for tuning in. I hope this helps, and miss you guys. Hope you're doing well out there. I'll talk to you soon. And remember, you can shoot me an email if you need me. And I'm going to answer emails between 10 and 12 every day, and then I'll try to do it a little bit, one more time towards the end of the day. So thanks a lot. Talk to you guys soon. Bye.